Hello, scholars. Welcome to the first lesson of Unit 4 on the conic sections. The conics can be defined in analytic geometry as the curves that are formed when a two-sided cone is intersected by a plane. And I found a nice graphic here for us to look at. You can see the cone that I have a picture of here. And the cone has two parts. They're called the napes of the cone, but that doesn't really matter. You've got two parts of the cone, and if you slice it just parallel to the top and the bottom of the cone, the bases if you want to call them that, you can see that you get a circle. The red ones are the circles, and you can see two of them represented there. If you tip that plane a little bit so that it cuts through the cone at an angle, you get an elongated circle, which we call an ellipse. Those are the yellows that you see on the cone. And then if you cut it through only one section of the cone, if you slice it just so that it only touches one piece of the two napes, then you get a parabola. And we've studied parabolas before, so that should look familiar to you. And then if you cut it where it cuts through both napes of the cone at the same time, you get two parabola type shapes back to back, and those are called a hyperbola. And we've also studied those a little bit when we studied rational functions. So looking at it geometrically in 3D, we're talking about a cone being intersected by a plane. Algebraically, we're talking about quadratic relations. Now, we've studied quadratic functions before, but the reason these are called quadratic relations is because they may not necessarily meet the standard for being a function. So we'll talk about that as we go along. Today I'd like to go over with you what the equations look for a circle and an ellipse. And you're going to recognize x and y, the two variables x and y, coming from the x and y axis and representing a point in the two-dimensional plane. And you're also going to see x squared and y squared when we're talking about the circle and the ellipse. So we're going to have both variables being squared. So a circle can also be defined as the set of all points that are equidistant from a given point, which is called the center. So if we have a point that's our center, and we find all the points that are exactly a certain distance away from that point, and we collect all those points, you're going to see that we get a circular shape. And if we connect all those points, we get this. Now the center is not actually part of the circle, but it's a point used to define the rest of the points. And the equation for the set of points like that looks like this. It's going to be something minus, well, let's call it x minus h squared plus y minus k squared equals r squared. And in that form, which is called the standard form for the equation of a circle, you're going to have h comma k being the center of that circle. And then r, if you take the square root of the variable that's over on the other side, on the right side of the equation, you'll get the radius of the circle, which is that distance we were talking about that defines all the points. So the radius of the circle is going to be r. So a nice example, let's start off with an easy one, would be something like x minus 3 squared plus y plus 5 squared equals 16. Okay, so to find the center of that circle, you're going to look here and here inside the parentheses, and you're going to take the opposite of what you see there. So minus 3, you're actually going to say the center of that is positive 3. And then you're going to take the opposite of what you see, just like what we did when we had parabolas in vertex form. You're going to take the opposite of that, and so you're going to get negative 5. So the x and y coordinate of the center of that circle are 3 comma negative 5. And then the radius is going to be the square root of the number that's over on the right side. And so the radius of this particular example that I made up is going to be 4. Now, if you get lucky and you have a circle that has its center at 0, 0, the equation becomes even shorter, because then you have x minus 0 squared plus y minus 0 squared equals whatever the radius is, let's say 81. So in that case, the center is at 0, 0, and the radius is 9, because the square root of this number here. And normally we would not write x minus 0 squared or y minus 0 squared. We would just put x squared plus y squared equals 81. And that's a nice simple circle centered exactly at the origin with a radius of 9. Okay, so that's the general equation for a circle, and if it's given to you in that form, in standard form, it's beautiful because then you can see the center and you can tell what the radius is by just looking at the equation and taking one simple square root. but oftentimes the circle isn't given to you in standard form. It's given to you all multiplied out. Somebody has multiplied everything out. There's no more parentheses in there, and you need to work backwards and put it back into standard form. So that's what we're going to spend our time doing in the homework assignment today. I'm not just going to give you a circle that's already in standard form. I'm going to give you one that's multiplied out. You're going to work backwards and use your factoring skills, and you're going to do what's called completing the square. Now, if you were in my class last year, you learned how to complete the square when we put parabolas in vertex form for graphing purposes. So this should look familiar to you, but we have to do completing the square for both the x and the y variable. So here's what I'm talking about. You're going to see something like this. You're going to see x squared plus y squared, but then there's going to be some other terms like this. So somebody has multiplied all that out, they've FOILed out the two binomials, they've moved the constant term over to the left, and it's set equal to 0. So in this form, we can tell it's still a circle because we see that x is squared and y is squared, and there's plus in between the two. That tells us that this is a circle. Later on we'll learn about what to do if it's subtraction in between there. But because both x and y are squared and there's plus in front of the y squared, and the x squared, they're both positive, we know that this is a circle. So the technique called completing the square means that we're going to create the perfect square situation so that we can get into that nice factored form that we're looking for. Remember, we're looking for this form right here. X minus h squared, y minus k squared equals a constant squared. Okay, so what I'm going to do is I'm going to put the x's together. So I have an x squared term and I have a minus 4x term. I'm going to put those on the far left. After that, I'm going to put a plus blank. And we'll fill that in just a minute with a number that we choose exactly the right number to make that a perfect square. We're going to do the same thing with the y's. We're going to put the y squared plus 2y together, and we're going to put a plus blank. We're going to, again, create a perfect square. Now that constant term minus 4, eventually I need all the constant terms over on the other side, so I'm going to move that minus 4 over to the other side and make it positive 4 over on the right. Okay, I haven't changed anything, I haven't added anything, I just kind of spread out the terms and moved the constant term over. Still the same relationship, it's just been rearranged. Okay, I would like this first part right here that I'm going to highlight in yellow, I would like that to be a perfect square so that I could factor it so that it looked like that. So to make that happen, I need the number in the blank to be exactly half of the middle term squared. So half of negative 4 would be negative 2. And if I squared it, negative 2 times negative 2 would be positive 4. If I had a 4 right there, this would factor into x minus 2 squared. If you don't remember how to factor a perfect square, you might want to review that, but x squared minus 4x plus 4 factors into x minus 2 times x minus 2. FOIL it out if you don't believe me. Okay, so if I had a plus 4 right here, I would have a perfect square, and then it would look like what I want it to look like to be standard form. So I'm going to make that happen. I'm going to add 4 on the left to make that happen, and I'm also going to add 4 on the right to make that happen. To balance it out. That way I haven't changed the relationship, I've just added 4 to both sides. It's still an equal expression. Okay, now the second one, let me change highlight colors here. Let's go with this one now. We want to make that into a perfect square so that it looks like this. We want the y squared plus 2y to be plus just the right number so that we can factor it into something squared like that. So again, this would be a perfect square if the number that was in the blank was exactly half the middle term squared. So half of positive 2 is positive 1, and if I square it, I get 1. That would make this factor into y plus 1 squared. But I can't go adding 1 without adding 1 over on the other side as well. So I do that, and I've created this perfect square. On both the x and the y terms are now both perfect squares. And on the right side, I had 4 originally, but I added a 4 and a 1, so I have a total of 9. Now look at it. It's in standard form, and I can tell you exactly what the center of this circle is and the radius of this circle. This one worked out nicely. The center is at positive 2. Remember, it's the opposite of this number right here. Negative 1, the opposite of that number right there. And then the radius is the square root of the number that's over on the right side of the equation. So the square root of 9 is 3. So I now know the center and the radius of this circle. It started out in non-standard form, but I was able to do completing the square twice so that I could actually read it in standard form and be able to see the center and the radius very easily. So that's called completing the square. And again, we did that last year. If you don't remember it, we're going to review it quite a bit in this homework assignment. Okay, let me do another one. I'm going to do 3 examples of circles, and then we'll move on to the next shape. This one, it's going to go x squared plus y squared plus 4y minus 117 equals 0. Okay, I know that this is a circle because I have both x and y squared, and they're both positive. But I don't have any other x terms, just x squared. That's a little bit curious to me, but let me put it first, and then I'm going to put y squared plus 4y. And then remember, I'm going to move the constant term, the negative 117, over to the right side of the equation and make it positive 117. Okay, so completing the square with the x's, there's nothing to do there. That is going to be basically x minus 0 squared. You can just leave it x squared if you want, or if you want to write it as x minus 0 to remind yourself that the x coordinate of the center of this circle is going to be 0. That would be great. All right, the second one, I need to make this one into a perfect square. So I need to pick just the right number to go in the blank so that it's half of the middle term divided, or squared, sorry. Half of 4 is 2, squared would be 4. If I put a plus 4 there, I have to put a plus 4 over on the right side as well to balance it out, but I have created a perfect square. I've created y plus 2 squared. And that's great. That's what I need to have it in the correct form. This adds up to 121, and now I see that my standard form circle is x squared plus y plus 2 squared equals 121. The center of this is 0, negative 2. Remember, there's no other x term, so it has to be 0. And the radius is the square root of 121, which is 11. Pretty nice one. Okay, the last one. This is where it gets a little bit more complicated. We're going to have 4x squared plus 4y squared minus 16y minus 24y minus 28 equals 0. Okay. The difficulty we have is that we have not just x squared and y squared. So factoring when there's something in front of the x, a coefficient other than 1, we always know that that's a little bit more challenging. So if there's any way we could get rid of those 4's that are in front of the x squared and the y squared, then we wouldn't have to worry about factoring a leading coefficient other than 1. So I'm going to do a quick check. Since 4 and 4 are the same, we have the same coefficient on x squared and y squared, I could factor it out, or maybe I could even divide it out. Let me check all the other numbers. All the other numbers in this particular example are divisible by 4. So it would not do any harm to factor out that 4 or divide out that 4. So I'm going to divide everything by 4, including the 0 on the other side. So I get x squared plus y squared minus 16, no, not 16. If I do 16 divided by 4, I don't get 16, I get 4. Minus 6y minus 7 equals 0. Okay, now it looks more manageable. I'm going to put the x's together. Did anybody catch my mistake? I see right here, this should be a x. When I wrote down the original problem, I put y for both variables. Let me see if that's what I was supposed to have. Yes. Okay, so I'm going to go x squared minus 4x, put those two together, leave a blank so I can complete the square. Y squared minus 6y, leave a blank so I can complete the square. Move the negative 7 over to the other side, and then I'll go ahead and put my 2 blanks on the right side to balance out the ones I put on the left. Okay, again, to make that perfect square, I take half of the middle term and I square it. Half of negative 4 is negative 2, so this is going to be x minus 2. But when I square it, I'm going to get positive 4. That will factor into x minus 2 squared. Do the same thing for the y's. To create that perfect square, I'm going to take half of negative 6, which is negative 3, and square it and get positive 9. So I'm going to get y minus 3 squared. So in their factored forms, they're standard form. But this is what I need to look at right here. I added 4 so I need to add 4 on the right. I added 9, so I need to add 9 on the right. When I add that up, what do I get? 13, I get 20. Okay, I'm glad that we did this example because I want you to see that the radius does not always work out to be a nice integer value. In this case, the center is at 2, 3. You can see that, the opposite of this and the opposite of this. There's the center. But the radius is the square root of 20. The square root of 20 is somewhere between 4 and 5 if you're looking for the decimal value, but we usually prefer to give it as an exact value, so you need to remember how to simplify a radical. So 20 can break down into 4 times 5. I'm going to take the square root of 4, which is 2, and leave the 5 inside because it's a non-perfect square. So the radius is 2 square root of 5. And that's a little bit more than 4, but less than 5. But we want to give it in its exact form. All right, so that's how you complete the square with circles. Now, some of the questions you're going to have might ask you to find the center of the circle. And so you have to do the completing the square to be able to answer that question. It might ask you to find the equation of the circle knowing the endpoints of the diameter. So then you'd have to find the midpoint so that you could find the center of the circle. So there's lots of different variations of these problems, but in the end, if you know how to complete the square and if you know the standard form for the equation of a circle, you should be fine. All right, I'm going to make a separate video for ellipses. So let's start with circles, and I'm going to close this video now. Thanks, guys. Bye.